Hi guys, welcome to Skholar IAS, your one-stop solution for UPSC preparation. Myself, Biswajit Sir, your faculty for Geography. So in the last class, we have started with the topic of interiors of the earth, where initially we have talked about the direct and indirect evidences, and then we have talked about your earthquake waves and how it propagates. So today again we will continue with the same topic of interiors of the earth, where there are other dimensions which are associated with it. Hi guys, so in the last class we have started with the topic of interiors of the earth, where we have talked about initially about the direct and indirect sources which gives us evidence about the interiors of the earth, and then we have also talked about your different types of earthquake waves and how it propagates, especially your body waves, that is your P and S waves, right? So moving on, we will continue with the same chapter of interiors of the earth, where the first thing that we are going to discuss is your different types of earthquake waves, right? Then moving on, we will also talk about the interiors of the earth. What are the different layers that we find? For example, we have the crust, we have the mantle, and then we also have the core, right? So these are the things that we are going to deal in today's class. All right, so let us begin by first talking about your different types of earthquakes. So what are the different types of earthquakes? Always remember, the type of earthquake waves are different from type of earthquakes. Type of earthquakes basically is determined on the basis of its origin, how it originates. Fine. So first one, the most common ones are the tectonic earthquakes, meaning because of the movement of the tectonic plates or your lithospheric plates. In our previous classes, we have also discussed about the lithosphere not being a uniform body, but it is broken down into several plates, which we call it as the lithospheric or your tectonic plates, right? And because of the movement and the interaction, we get what type of earthquakes? We get tectonic earthquakes, right? And these are generated due to sliding of the rocks along the fault plane. So on one way on how we can have the tectonic earthquakes, by the movement of the tectonic plates, and secondly also because of the sliding of the rocks along a fault plane, meaning if this is a rock layer and if we have a fault here, right, and because of the faulting, this portion will either move down or this portion will move down. Since there is a displacement of the rock layers that is taking place, we will get tectonic earthquakes. Understood? Second, a special case of tectonic earthquakes is sometimes recognized as a volcanic earthquake. However, these are confined to areas of active volcanoes. So as your volcanoes rise, what happens? It results in trembling of the earth's surface, right? And because of this trembling, we call it as a type of earthquake, that is your volcanic earthquake. Fine. Then in the areas of intense mining activity, sometimes the roof of underground mines may collapse, causing minor tremors, and we call this as your collapse earthquakes. Fine. Then we have the ground shaking, which may also occur due to explosion of chemical or because of your nuclear devices as well, and such tremors are called as your explosion earthquakes. And lastly, your earthquakes that occur in the areas of large reservoirs, that is your dams, are referred to as your reservoir induced earthquakes, or which are also called as your RIS, meaning your reservoir induced seismicity. Fine. So first one is your tectonic earthquakes, second one is because of your volcanism, that is your volcanic earthquakes, thirdly because of your mining activities, which we call it as the collapse earthquakes, then we have explosion earthquakes, and then we have reservoir induced seismicity or earthquakes. Fine. So these are the different types of earthquakes. Then moving on, let us also talk about how we measure earthquakes. Fine. So your earthquake events are scaled either according to their magnitude or intensity of the shock. So there are two ways on how we classify the earthquakes. Number one is on the basis of its magnitude, and second one on the basis of intensity, meaning how much damage it has caused. Fine. So the magnitude scale is known as the Richter scale. So Richter scale is used to measure the magnitude of the earthquake. Fine. And the magnitude relates to the energy which is released during the quake. So your intensity talks about your physical damages which are caused by the earthquake, whereas on the other hand, magnitude talks about the amount of energy which is released during an earthquake, right? And this magnitude which is measured with the help of Richter scale, it is measured in the number between 0 to 10. 0 referring to the least energy released, and 10 is the maximum energy released, right? So this is about the Richter scale. Then let us talk about intensity. The intensity scale is named after Mercalli, who is a very famous Italian seismologist. Fine. So we have two scales, Richter scale and Mercalli scale. And the intensity scale of the Mercalli scale takes into account the visible damage which is caused by the event, meaning physical damages caused by the earthquake. And the range of intensity scale is from 1 to 12. So Richter scale talks about magnitude and it is measured from 1 to 10, whereas on the other hand Mercalli scale talks about the physical damage or intensity which is measured from 1 to 12, right? So these are the two different ways on how we measure the earthquakes. Fine, fairly simple. Now next is what are the different effects of earthquakes. Fine, your earthquake is, of course, it's a natural hazard, and following are the immediate hazardous effect of the earthquake. Always remember, earthquake need not necessarily be a natural hazard. It can also be artificial, because mining is a human activity, nuclear explosion is a human activity, right? So earthquake can be because of both your natural hazard and because of your artificial hazards as well. Fine. Okay, so what are the different hazardous effects of earthquake? First, ground will shake, then differential ground settlement, land and mudslides, then we will have soil liquefaction, then we will have ground lurching, we can have avalanches, we can have ground displacement, we can have floods from the dams and levee failures, we can have fires, structural collapse, as well as falling objects, as well as tsunami. Fine, so tsunami is an effect of earthquake, very important, right? So the first 6 listed above have some bearing upon the landforms, because your landforms are getting displaced or disfigured, right? Therefore the landforms in that particular area where your earthquake is occurring, it will have certain kind of changes, right? While others may be considered the effects causing immediate concern to the life and properties of the people in the region. Fine. Then the effect of tsunami would occur only if the epicenter of the tremor is below the oceanic waters and the magnitude is sufficiently high. So what is the source of origin of tsunami? Tsunami basically is an effect of earthquake. And where is the epicenter? The epicenter is below the oceanic water, right? And as the energy is released from the epicenter, what will happen? It will result in your water being displaced and your huge amount of crest and troughs will be developed, which will move towards the land areas, causing damages to the life and property. Fine. Your tsunamis are the waves which are generated by tremors and not an earthquake in itself. Fine. So as the earthquake releases energy, what will happen? As it releases energy, this energy will travel via the water bodies, and these water bodies will displace, it will develop crest and troughs, and this moves towards the land areas, right? So though the actual quake activity lasts for a few seconds, its effects are devastating provided the magnitude of the quake is more than 5 on the Richter scale. So the plausible, how do I put it, the reason why a tsunami will be formed, or the tsunami usually occurs when the earthquake has a magnitude of more than 5 on the Richter scale. Understood? Very, very simple. Okay, so this was all about your earthquakes. First we have talked about your different types of earthquake waves, then we have talked about how it propagates through the body of the earth, then we have also talked about the different types of earthquakes and how we measure it as well, right? Then based upon how the P waves and S waves travel through the body of the earth, we can determine the structure of the earth, right? That means the different layers of the earth. For an example, in the last class we have seen that the S waves were not able to travel beyond 103 to 105 degree, meaning there is a presence of this semi-molten layer which we termed it as the outer core, right? So based upon the evidences of studying your seismicity, we have classified the structure of the earth or the interiors of the earth into 3 different layers: the crust, the mantle, and the core. So first let us talk about the crust. So it is the outermost solid part of the earth, right? So if this is the interior, see, this is the radius, right? This is the surface and this is the center point, and radius is how much? It is around 6378 kilometers. Fine. So at the outermost, what do we have? We have the crust, and it is brittle in nature. Very, very important point. The thickness of the crust varies under the oceanic and your continental areas. In the lower classes, we have seen how the crust looks like. It looks like a dumbbell shape, right? This is how the crust looks like. This thick portion refers to the continental crust, and this thin portion refers to as your oceanic crust. And which one is denser? Your oceanic crust is denser compared to that of your continental crust, right? So this is how the crust looks like. It is not uniform in thickness. Continents are thicker, oceans and the oceanic crust are thinner. Fine. Your oceanic crust is thinner as compared to the continental crust, and the mean thickness of the oceanic crust is about your 5 kilometer. So this thickness is about your 5 kilometer, whereas the continental is around your 30 kilometer. So this thickness is about your 30 kilometers. Fine. Then the continental crust is thicker in the areas of major mountain systems, very important, and it is as much as 70 kilometer thick in the Himalayan region. So wherever your mountain systems are present, there you will notice that the continental crust is much more thicker and it can extend up to 70 kilometers as seen in the Himalayan region, right? So this was all about the crust. So below the crust, what layer do we find? Very simple, we have learned already, it is the mantle. Fine. So the portion of the interior beyond the crust, it is the mantle, and the mantle extends from your Mohos discontinuity at a depth of 2900 kilometers. Fine. So what is the distance up to which your mantle can be found? It can be found up to a depth of about your 2900 kilometers as shown in this figure, right? So till what distance we find the mantle? Here up to this distance, that is your 2900 kilometers. Fine. The upper portion of the mantle is called as the asthenosphere. Fine. So the now we have understood what is a lithosphere. Lithosphere is what? Lithosphere is nothing but the crust plus the upper part of the upper mantle, and below the lithosphere, what do we have here? We have another semi-molten or a semi-liquid layer, which we call is as the asthenosphere. And why do you think that the lithospheric plate or the tectonic plates are moving? They are moving because this asthenosphere is present just below the lithosphere, right? So this asthenosphere will either move to the right or it will either move to the left, right? And if the asthenosphere, which is semi-molten in nature, if it moves to the left, the lithospheric plate will move to the left. And if the asthenosphere is moving towards the right, it will or flows towards the right, then the lithosphere will also flow towards the right. And where is this asthenosphere present? It is present in the upper portion of the mantle just below the lithosphere. Fine. The word astheno means weak. It is considered to be extending up to 400 kilometers. So what is the extent up to which depth do we find the asthenosphere? We find it up to a depth of 400 kilometers, and it is the main source of magma that finds its way to the surface during the volcanic eruptions, right? So this asthenosphere is semi-molten in nature, meaning it is made up of what? It is made up of magma, and sometimes this magma can intrude through the lithosphere, right? It can intrude through the lithosphere, that means it will break the lithosphere and reaches the surface of the earth, right? So asthenosphere are the regions of origins of volcanism. Very, very important. Fine. Then the crust and the uppermost part of the mantle is called as the lithosphere, like we have already seen in this diagram, and its thickness is about your 100 to 200 kilometers. So this lithosphere is found from where? It is found between 10 to up to 200 kilometers, right? And from 200 kilometers to 400 kilometers, what do we find? We find the asthenosphere. Understood? Very simple. Then below the upper mantle, what do we have? We have the lower mantle, and this lower mantle extends beyond the asthenosphere and it is solid in state, unlike the asthenosphere. Fine. So what is the total depth up to which the mantle is found? It is found up to 2900 kilometer. Fine. Then below the mantle, what do we have? We have the core. Again, the core is of two types. We have outer core and we have inner core. Your outer core is of course semi-molten in nature, as evident by the propagation of your S waves, and below the outer core we have the inner core, which is solid in nature. Fine. So as indicated earlier, the earthquake wave velocities helped in understanding the existence of the core of the earth. The core mantle boundary is located up to a depth of or at a depth of 2900 kilometers. Fine. So what is the boundary of core mantle? It is 2900 kilometers. So your mantle ends and your core starts. The outer core is liquid state while the inner core is solid in state. The core is made up of very heavy materials. For example, it is made up of nickel, iron, etc. Right, and mostly constituted by nickel and iron, and it is sometimes referred to as the knife layer. Knife meaning nickel plus iron. Now you can ask me a question here, why the outer core is liquid in state and why your inner core is solid in state, because as we move below the interiors, or as we move from the surface of the earth towards the interiors, what happens? Your temperature keeps on increasing. Then how is your inner core solid in nature? Because if your temperature is at its maximum at the inner core, it should have been in the liquid state, right? But the answer is no. Why? Because as we move below, both your pressure increases as well as your temperature increases. In case of your outer core, your temperature plays a more dominant role compared to your pressure, and because of which the outer core is liquid in nature. But in case of your inner core, your pressure plays a more dominant role compared to temperature, and because of which the inner core is solid in nature. Understood? Okay, so this was about the different layers of the earth, right? Then moving on to the next topic, let us also talk about what are volcanoes and what are the different types of volcanic landforms, right? So this will be the last topic of today's discussion, but it is very, very important. So a volcano, what is a volcano? How do we define volcano? A volcano is a place where gases, ashes or molten rock material, which we call it as the lava, escapes to the ground. Fine. A volcano is an active volcano if the materials mentioned are being released or have been released out in the recent past. And the layer below the solid crust is the mantle, right? Now this is again a very, very important point, right? See, here, this is the surface, Earth's surface, right? So where is the magma originating? Like it is said in the last slide, that it is originating mostly in the asthenosphere, that means in the mantle. So as the magma flows in the upward direction, it intrudes the lithosphere and reaches the surface of the earth, right? So here we have magma, and if the magma reaches the outer surface, or once it is found in the earth's surface, we call it as the lava. So magma, we call it as magma when it is found below the earth's surface, and once this magma is found above the earth's surface, we call this as the lava. Understood? Very, very simple. Okay, so now we have the mantle from where the your magma is coming out, right? So now this is very, very important. Like this whole section that you see here, it basically talks about your magma being referred to as lava when it reaches the outer surface, right? Very, very simple. Fine. So the material in the upper mantle portion is called as the magma, and once it starts moving towards the crust or it reaches the surface, we refer to it as lava. And the material that reaches the ground includes your lava flows, it includes your pyroclastic debris, it includes your volcanic bombs, ashes, dust and gases such as nitrogen compounds, sulfur compounds and minor amounts of chlorine, hydrogen and argon. Very, very important from your prelims perspective, right? So as a homework, kindly go through this point. Okay, what are the different gases? What are the different gases which are released during a volcanism? This question has been asked in your previous UPSC examinations. Okay, so this I will mark it as very, very important, right? Kindly try to remember the different types of gases released. Fine. Okay, so this was about volcanism, how it originates, right? Now let us talk about its classification. Your volcanoes are classified on the basis of nature of eruption and the form developed at the surface, right? So classification is done on the basis of nature of eruption as well as what kind of landforms are developed at the surface, and based on these the major types of volcanoes are as follows. Fine. Now before we proceed to understand the different types of volcanoes, we have to understand that the lava that I am talking about, they are of two types. Okay, lava are of two types. One we have is your basic lava excuse me, and another one is called as your acidic lava. The difference between basic lava and acidic lava is that basic lava has less amount of viscosity, meaning it will flow horizontally, but in case of acidic lava, its viscosity is very, very high, therefore it flows vertically. Okay, so your basic lava will flow horizontally, but acidic lava, since its viscosity is very, very high, it usually does not flow horizontally, but it piles up because the friction is very, very high, and as it piles up we get steep structures. Okay, so this difference you have to understand between basic lava and your acidic lava. Fine. Okay, so depending upon the different types of landforms that we have, the first type of classification that we see is called as a shield volcanoes. Fine. So bearing the basalt flows, the shield volcanoes are the largest of all the volcanoes, very, very important on the earth. For example, the Hawaiian volcanoes are the most famous examples. And these volcanoes are mostly made up of basalt or your basic lava. Very, very important. Your basalt is an example of your basic lava. Therefore, this type of lava is very fluidic in nature. Fine. So, as the magma moves up, as the basaltic magma moves up or the lava comes to the surface, it will flow horizontally in both the direction. Therefore, what kind of structure we will see? We will see a structure of this kind, meaning its length will be very, very high. Okay, it will be its width will be very high, but in terms of height it will be less. For example, Hawaiian Islands. Fine. For example, your Hawaiian volcanoes. Understood this? So what kind of structures do we see in a shield volcano? This is the kind of structure that we see. It will have large extent, but its height will be very, very less, because your lava flows horizontally in both the direction, left and right. Okay, it does not pile up vertically. Understood? Okay, so for this reason, these volcanoes are not steep like we see in this diagram. They become explosive if somehow water gets into the vent. Always remember, yes, basic lava, it flows horizontally or it is fluidic in nature, but it is also much more hotter or explosive compared to that of your acidic lava. Fine. So they become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. Okay, the upcoming lava moves up in the form of fountain and throws out the cone at the top of the vent and develops into a cinder cone. Fine. So as the magma moves up, what happens? As the lava moves in the form of a fountain and throws out the cone. So here usually we had a cone, right? But this cone with time disappears, okay, or it is thrown out at the top and it develops into a cinder cone. So this is the structure of a cinder cone. So this vertical structure that you see here, this triangular, this portion gets removed out. Fine. Okay, then the next type of volcano that we have is called as your composite volcano. So these volcanoes are characterized by eruptions of cooler and more viscous lava than basalt, which we call it as your acidic lava. Fine. Understood? So acidic lava, as we all know, it is cooler and it also has high amount of viscosity. So what kind of structure we will see? By common sense, we can say we will see a steep sided volcano, right? So these volcanoes often results in explosive eruptions. So which is much more explosive? Okay, always remember, acidic lava is much more explosive compared to your basaltic lava, but temperature is more for basalt and not acidic lava. Fine. So along with the lava, large quantities of pyroclastic material and ashes find their way to the ground. This material accumulates in the vicinity of the vent openings, leading to formation of different layers, and this makes the mountain appear as composite volcanoes. Understood? Very, very simple, right? So we will get different layers. This is how the volcano will look like, because since it is highly viscous in nature, what happens to the lava? The lava accumulates in different layers, and because of which its steepness keeps on increasing or its vertical height keeps on increasing. Fine. Okay, then we have to understand what is a caldera. Now these are the most explosive of the Earth's volcanoes. They are usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. So your caldera are nothing but a variant of acidic volcano, but it is much more acidic compared to a composite volcano, right? They are so explosive in nature that this top portion that you see here, this will no longer exist. It will burst out. Fine. So they are usually so explosive when they erupt, they tend to collapse on themselves. So as this upper portion tends to collapse, it will collapse within itself. And because of this, in this upper portion, a huge depression will develop, and this depression is called as the caldera. Understood? Fine. So the collapsed depressions are called as the calderas, and their explosiveness indicates that the magma chamber supplying the lava is not only huge, but it is also close to the vicinity. Fine. So these are your different types of volcanoes. Now we have another categories of volcano. One is called as the flood basalt provinces. Now what are these flood basalt provinces? Again, we have the term basalt, meaning what? Meaning again it will have a horizontal flow, meaning it is fluidic in nature. Therefore we will get a structure which has a huge extent horizontally, but steepness will be very, very low. So these volcanoes outpour highly fluidic lava that flows for long distances. Some parts of the world are covered by thousands of square kilometers of thick basaltic lava flows, and there can be a series of flows, with some flows attaining thickness of more than 50 meters, right? So it can have a vertical extent up to 50 meters. Your individual flow may extend for hundreds of kilometers. For example, the Deccan Traps of India, which is found where? Deccan Trap is found along the your northwestern part of Maharashtra, along the south east part of your Gujarat, that region, right, is called as the Deccan Trap, because a basaltic lava flow took place in that area, right? Your Deccan Trap from India, presently covering most part of the Maharashtra plateau, are much large flood basalt province, right? So your, if this is India, this section that you see here, this area has the basaltic flow, right, where your basaltic volcanic eruption took place, which we call it as the Deccan Trap, right? So this Deccan Trap region is an example of a flood basalt province, very, very important from exams perspective, right? Then it is believed that initially the trap formations covered a much larger area than the present or the contemporary times. Understood? Lastly, what we have is something which is called as your mores. Mores refers to your mid-oceanic ridges. Ridges are nothing but a type of mountain. Fine. So, or we can call it as a mountain-like structure. Fine. So, these volcanoes occur in the oceanic areas. Mid-oceanic ridges, meaning ridges or mountain-like structures which is found along the middle section of the ocean, right? So along the center of the ocean we find structures which we call it as the mid-oceanic ridges. Fine. So these volcanoes occur in the oceanic areas, and there is a system of mid-oceanic ridges of more than 70,000 kilometers long that stretches through all the ocean basins. So be it your Atlantic, Pacific or Indian Oceans, mid-oceanic ridges are found is found in all the ocean basins, right? And the central portion of this ridge experiences frequent eruptions. Okay, now suppose this is a landmass. Now here we have a water body, right? Suppose this is landmass 1, this is landmass 2, and in between we have the ocean, right? So in the middle portion of the ocean, what we will find? We will find mid-oceanic ridges which extends along the length or along the whole length of the ocean basin, right? And what is the origin of the mid-oceanic ridges? It is nothing but the magma which is flowing from the asthenosphere towards the Earth's surface and intruding or breaking the lithosphere, resulting in formation of a mid-oceanic ridges, right? And from this your magma will flow in this direction as well as in this direction, right? So what is the source of origin of mid-oceanic ridges? It is nothing but the volcanic eruptions which is taking place on the oceanic crust. Understood? So these are the different types of volcanoes. Now since we have understood the different types of volcanoes, let us also talk about your different types of volcanic landforms. Okay, now landforms are of two types. One is called as your extrusive landforms, another one is called as your intrusive landforms. Now what is the difference between intrusive and extrusive? The landforms which has been formed on the surface of the earth, we call it as extrusive, like for example shield volcano, composite volcano, calderas. These are examples of extrusive volcanic landforms, right? Then we have intrusive, which are formed below the surface of the earth, right? So but the question is, why do we find intrusive landforms? For an example, as the magma moves up, your lava flow will take place here, and because of which we get different types of volcanic landforms or extrusive volcanic landforms, right? But if the magma, as it moves towards the surface of the earth, even before reaching the surface of the earth, if it cools down in this area, if it cools down and solidifies here, we get different types of landforms which we call it as intrusive, meaning landforms which are found below the surface of the earth. Okay, so let us go through the different intrusive landforms point by point. Okay, the lava that is released during the volcanic eruptions on cooling develops into igneous rocks. So what is the source of origin of igneous rock? It is nothing but the volcanic eruptions, right? That is the magma. The cooling may take place either on reaching the surface or while the lava is still in the crustal portion. And depending upon the location of the cooling of the lava, igneous rocks are classified into volcanic rocks, or it is also classified as your plutonic rocks. Very, very important, right? So now we all know because the lava or the magma cools down, we get igneous rocks. Igneous rocks are of two types. Number one is called as your volcanic rock, and then we have your plutonic rock. Now what is the difference between volcanic and plutonic igneous rock? Volcanic igneous rocks are those rocks which has been formed by the cooling of the lava at the surface of the earth, whereas your plutonic igneous rocks are those igneous rocks which has been formed because of the cooling of the magma below the surface of the earth. Understood? It's similar to that of your extrusive and intrusive. Fine? Okay, then the lava that cools within the crustal portion, that means below the surface of the earth, assumes different forms, and these are called as your intrusive forms, like we have already explained, right? Now because of the magma cooling below the surface of the earth, we get different types of intrusive landforms, and the first one that we are going to talk about is the batholith. So this is where the batholith is found. Now let us understand what is this batholith. It is a large body of magmatic material that cools in the deeper depth of the crust, develops in the form of large domes. So these are, what is the structure of batholith? These are large domes, right? And they appear on the surface only after denudational processes, after the removal of the overlying materials. So these batholiths at times can get exposed to the surface of the earth if this section gets removed because of the processes like erosion and weathering. If the upper layers are removed, your batholiths at times can get exposed to the surface of the earth. Fine. And they cover large areas and at times assume depth that may be several kilometers, and these are granitic bodies. Very, very important. Your batholiths are made up of what? Your batholiths are made up of granites, and granite is an example of intrusive igneous rock, right? Your batholiths are cooled portion of the magma chambers. So this was the first structure. Then what is the second structure that we have? These are called as your laccoliths. Now what are laccoliths? These are large dome shaped intrusive bodies with a level base and connected by a pipe like conduit from below. So this is how a laccolith looks like. It's a dome like structure which is having a flat base, and your magma supply is done by a pipe like structure which is found just below the laccolith. Fine. So it resembles the surface volcanic domes of composite volcanoes. So it looks somewhat like the composite volcano, only these are located below the surface of the earth, and it can be regarded as the localized source of lava that finds its way to the surface. So at times this can also be found along the surface of the earth, right, because of your denudational processes. For example, the Karnataka plateau is spotted with domal hills of granitic rocks, and most of these now exfoliated, meaning it has undergone physical weathering, are examples of laccoliths or batholiths, right? So Karnataka plateau, we find a lot of examples of laccoliths and batholiths. Fine. Then we have two important structures called as your lapolith and phacolith. So let us understand this. So as and when the magma moves in the upward direction, a portion of the same may tend to move in the horizontal direction whenever it finds a weak plane. Okay, let us go to the points, then I will draw the diagram. So it may get rested in different forms. In case it develops into a saucer shaped concave to the sky body, it is called as your lapolith. Now what is a lapolith? So as the magma moves in the upward direction, what happens? It encounters a very weak layer, and because of this the magma starts to get deposited in the form of a concave shape even before reaching the surface of the earth, and these type of structures are called as what? It is called as your lapolith. Fine. Then a wavy mass of intrusive rocks at times is found at the base of the synclines or at the top of anticline in folded igneous country. Such wavy materials have a definite conduit to source beneath in the form of magma chambers, and these are called as your phacolith. Now what are phacolith? Now see, lapolith, if I have to talk about, it's of saucer shape, right? Now if I have to talk about phacolith, now what are phacolith? Phacoliths basically, again, as it encounters a weak plane, what will happen? Your material gets deposited in the form of this, like a wave. Okay, a wavy mass of intrusive rocks is found along the base of the syncline, meaning it is a structure of this kind. Syncline, we all know now, if this is a wave, this area is called as what? It is called as the syncline, and this is called as the anticline, right? Now we all know what is a syncline and an anticline, right? Okay, I did a mistake here. This is called as the syncline, and this is called as the anticline, right? Okay. So the materials which are getting deposited in the anticline as well as in the syncline in a wavy form, these type of structures are called as what? These are called as phaccolith, right? Understood? So lapolith are saucer shaped, whereas phaccolith have a wavy structure where your magma is getting deposited both in the anticline as well as in the syncline. Understood? So a wavy mass of intrusive rocks at times is found at the base of synclines or at the top of the anticline. This is the anticline, this is the syncline, right? In the folded igneous country, and such wavy materials have a definite conduit to source beneath in the form of magma chambers, and these are called as the phaccolith. Understood? Lapolith, and then we have your phaccolith, right? Okay, then what are the other types of structures that we see? Let us talk about. Fine. Then the near horizontal bodies at the intrusive igneous rocks are called as your sills or sheets, depending upon the thickness of the material. Now suppose if a material gets deposited along the horizontal layers. Now your lapolith was of this structure, your phaccolith was of this structure. That means it has a wavy portion, right? But in case of sills, they get deposited horizontally along the beds of the plane, and these are called as your sills. Understood? Okay, so depending upon the thickness of the material, and the thinner ones are called as sheets, while the thick horizontal deposits are called as sills. Now what is the difference between sills and sheets? Sills will have larger thickness, whereas sheets will have a smaller thickness, or it will be thinner. Fine. Okay, so then another type of intrusive landform that we have, these are called as your dikes. Okay, so when the lava makes its way through cracks or fissures developed in the land, it solidifies almost perpendicular to the ground. So your sills and dikes, the difference is that sills gets deposited horizontally, whereas your dikes are getting deposited vertically in this manner. Fine. So it gets cooled in the same position to develop a wall-like structure, and such structures are called as dikes. These are the most commonly found intrusive forms in the western Maharashtra area. So your dikes are found where? It is found in the western Maharashtra area, and these are considered the feeders for the eruptions that led to the development of the Deccan Traps, right? So sills, again, very very important. These are the horizontal structures, whereas dikes are vertical structures. Then we have your lapolith, and then we have the phaccolith, right? So this was all about the different types of volcanic landforms. Okay, so before we conclude, let us deal with two very important questions. First one, which type of volcanic eruptions have caused the Deccan Trap formation? 1. Shield, B. Composite, C. Flood, and D is caldera. Of course, it is a flood basaltic provinces like we have already seen. So your correct answer here is C. Right? Then which of the following describes the lithosphere? Number 1, upper and the lower mantle. B is core, crust and the core. C is crust and the upper mantle, and D mantle and the core. Of course, it is your crust plus upper part of the upper mantle. Therefore, your correct answer here is C. Okay, so this is where we will stop. Thank you. So I hope you understood today's topic, where initially we have talked about the different types of earthquakes. Then moving on, we have talked about how we measure the earthquakes, right, or what are the different scales to measure it. Then moving on, we have talked about the different interiors of the earth, or the different layers which are found inside the earth. And then finally we have also talked about your volcanism, and as well as we have talked about your extrusive and intrusive landforms which are associated with volcanism. So in the next class we will start off with a new chapter, and the name of the chapter is Distribution of Oceans and Continents. So stay tuned to Skholar for more such videos.